Hello, everybody, and good afternoon. What are we doing today? So, first of all, I want to thank everybody so much that has reached out commenting, saying that they were glad that I was background streaming. It feels good that people like watch the streams and miss the streams and are now happy that the streams are back. And so, I've got a lot of momentum right now to keep streaming from the positive feedback and lots of things that I want to mess around with, but also share at the same time. So, I just want to appreciate and say thanks to everybody that is watching and has watched. So, what are we doing? A little bit of it's kind of a break from the ESP32 journey, but it's the exact same stuff. This is all ESP32 all day long. But I want to talk. This is something I've been interested in playing with, and I figured I'd just do it in stream form because other people might find it interesting, which is the difference between streaming C and C++ streaming. Writing firmware in C versus C++. A lot of C++ haters out there, a lot of C haters out there, but the traditional like hardcore embedded people have this sort of like religious C only, and I am of the mind that I think C++ is the way to go if you can make it work, and actually you can make it work in a lot of situations. And but I don't have a lot of, I mean, I've done a bunch of production stuff. It's all C++. Um, and so I have actual experience delivering embedded things with C++, but I don't have the raw data that I would love to have comparing the two and really understanding where one of them, shortcomings and where they shine and don't shine and things like that. And so this isn't going to be a should you use C or C++? Again, that's a decision for you to make. For me, I always lean towards C++ for one reason. There's lots of reasons, but the one that wins out on over all the others is that you can do C in C++. You can't the other way around. Anything you can do in C, you can do in C++ with C code. So C code compiles straight away for the most part. There's some things that C++ calls you on. For the most part, in the C++ compiler, the inverse is not true. You can't just take C++ code and compile it in C. And so for that reason alone, I leave the door wide open. So if I want to and I can use C++, I will. But I start with C++. My files are .cpp, so the build system will compile them as C++. But what I want to do with this sort of like mini series, I don't know if you'd call it that, is comparing the two head to head. Like I'm going to do something in the C, maybe FreeRTOS ESP-IDF way, and then in the more portable C++ way, and then build it, kind of compare flash size, memory usage, and things like that. Hopefully we'll get into some profiling. I really want to talk about that in the little mini tool that I built for profiling on these things. And yeah, so anyway, today is probably going to be a little bit more boring because I want to set up the environment and we'll see how we go. All right, so let's start. For those that have not seen any of my broadcasts before, like I am a huge Docker fan for all of this development, and you will see right away that I have a .dev container in VS Code, so I can use dev containers. At the very bottom, I'm not sure. Yeah, you can see that on the stream. It says dev container, which means this is running inside of Docker, the dev environment itself, and there's really nothing to it. So I've got the dev container here. I won't go through this. I will just show it briefly. So if you want to pause and look at how I have it set up, you're more than welcome to do that. But all this does is set things up so that I can develop inside of a Docker container and not worry about dependency nightmares on my local machine. Back here briefly, you'll see I'm on version 4.4.3 of the ESP-IDF. So that's it for that. And then my main is very simple. It's this, at main. And it's printing debugging in VS Code over and over, which it's scrolled off the page so you can't really see it here, but this is constantly streaming every 1 second down here in this window. If I stop it and I pull it back up, you'll see it restarts, and then you'll see debugging in VS Code. And so that's where we're at. And so what I want to do is, this is a C++ way of writing this program. You can see I've included thread and chrono, and I'm doing a printf here of debugging VS Code, and then I do a standard this thread sleep for 1 second. So this is how I would do a threaded, this is how I would use the standard C++ stuff. I could then take this code, just FYI, and compile it on my local machine and run it, and I would get the exact same output, debugging in VS Code. What you can't do for a lot of, and as part of this, I'm going to be munging C and ESP-IDF C because I'll be using some of the free RTOS stuff. But you can't take that code and just compile it on your local machine because it's going to say, like, I don't know what the free RTOS task stuff is and port delay and all that means. And so I prefer to write it like this. It's a little cleaner, a little easier to read. It's also portable. I'm not as much concerned with the portability. Yes, Eager. Hey, welcome. Eager, if you're the same Eager from the Discord from Espresso, you're amazing. Love everything that you do for the community. Thanks for always being there to answer questions and hop on issues and things like that. For those that don't know, Eager, huge guy from Espresso, gets everything, knows the things inside and out, always willing to help. Thanks so much for everything that you do. And yes, so to your question, IO stream and standard stuff, that's an interesting one, which I'll do in a future stream. Those are expensive when it comes to flash memory. But so we're going to start small. But what I want to do today, and I don't know how long this will take, and it might, like I said, might be super boring. I want to get a build environment set up so that C and C++ build differently. One uses a C++ compiler. Well, I guess they could use the same compiler, but they compile differently. And what I would like to do is have like a main.cpp and a main.c that we could work in side by side, even in like a split screen view, that I could easily just from my command line build one, build the other, compare the flash sizes and things like that so we can get metrics on these things. But yeah, you're saying the same thing. IO stream, very costly in terms of flash. Yeah, it is. I did a test on that in a stream way back, Eager, that I found that the flash size difference was massive, prohibitively massive in my case. So, but yeah, all things that I want to measure and show in stream. So, I am not really prepared for this because I don't really know how to do this setup. So let's just, first of all, let me show what I'm trying to do here. So we're going to copy main.c. And let's just paste it. And let's rename it. Main.c. Okay, and now, this is slightly embarrassing, but I haven't written like an IDF getting started with like the free RTOS stuff in forever. And so I'm just gonna like go through the docs here for a second, and actually, I'm gonna go to the repo. The repo will have a good example. And just do a simple loop here, which I probably could figure out in the amount of time it's gonna take me to find, but this is the way we're doing it. Get started. Hello world. Main, nah, this is gonna be faster. Hello world main C. Okay, I'm gonna copy all of this code right out of the Espresso repo. Looks like it's 44 lines. Nope, 48 lines. Copy. And then let's delete all that. Okay, so our main.c is going to look like, and then we'll clean this up. Because it does things like this is chip with cores. We don't need to do any of that. It's really just this and the vtask delay. There we go. Oops. Okay, so, the way that I envision this going is I'm going to do split right. Hopefully this shows up okay. Yeah, it looks like it does okay. Let's pull this down some. And I've got main.cpp over here. Looks like 11 lines of code. And up here, let's get it to be the exact same. So we would do while true. Okay. Printf. Let's do I'm the C program. And we'll do task delay. We'll do every 5 seconds. And then over here, this is I just had cloned from another project. Say I'm the C++ program. And we'll change his sleep to 5 as well. Okay, so what we have here are identical, well, it should be, and I'll test it in a second here. Identical programs. They print a line, you know, that top level header, sleep for 5 seconds, and do that in an infinite loop forever. And, oh, this is, I need to reformat this. There we go. So they all have the same, I use 4 spaces. Sometimes I use 2, but actually, let's do it here as well because then it's consistent between the two. Okay. All right, so the way I have this set up now, though, is if I come into CMake lists, I've got IDF register, component register, sources main.cpp. It's going to build the CPP version of this. In my CMake lists at the top here, you can see I have my CMake CXX standard is 14, so that's C++ 14. I can go through some of this at a later time. You can see I've commented some stuff out that I'll like to talk about in future streams, but for right now, there's some compiler flags that I put in here to enforce some strict things in C++ that don't really apply to, some of it does to C, but it's mostly for C++. But what I want to figure out how to do is, like I said, I want to compile one version for C and one for C++. And I think what I can do is something like this that I've done before. So I'm going to just grab this really quick and come over into this CMake. And like I said, no idea if this is going to work. We're just flying by the seat of our pants here. Where if you have this right here, env, like if it detects the environment variable production, it'll say building, you know, message status building production. And then I add a compile definition, which again, I'll talk about in a future stream. But for now, I think this is a way to switch between the two. So if I say if env C version, we'll do that, then one thing. There's a way to do an else here. I don't really know it off the top of my head, so we'll just do this. This is going to be crude. I don't know if this is the best way to do it, but this is where we're going to start. I think this should work. We'll say building the C++ version here. And we'll say building the C version. Okay, and then I would just change the, I'm sorry. Blech. So in the case that I have C version as an environment variable, it would build, we'd want to build just main.c. And in the case I do C++, it should build the C++ version. Now, the trick with this is we're going to have to do full cleans and rebuilds, but that's okay. I'm just looking for an easy way that I can have this all in the same, like I don't want a separate like VS Code project for C and C++, and I'm switching between windows. I want to just be able to do it all in one VS Code session. And so let's see if this works. Let's close that out. Do a clear, make sure you can see this okay. All right, I'm going to do an idf.py full clean, which again empties my build directory, as you can see there. And I'm just going to do a if I don't define anything, I bet I get an error. But the way you would do this is like you would do C version equals 1 or equals whatever, just define the thing, and then you say idf.py build. And let's see if that works. I have no idea if it's going to work. Oh, okay, right. I'm going to scroll back up while that's building. And it says building the C version. See that right there? Which means it's running that. It says it again. Building the C version, building the C version. Does it one more time. And then we come through. C compiler, CXX compiler, and then it's going to come through and I assume build. Okay. That seemed like it worked. As a quick aside, like as part of these, I want to show how I handle building in a Docker environment in VS Code. If we come back up to the top here, you can see we have this dubious ownership in repository saying to add an exception, call this. Like, I don't like seeing this. It doesn't, in some cases, it causes like a hash not found message in the build output when you're building stuff. But what I'm going to do is I'm just going to take that. I have no idea if this is the right way to do it. This is how I do it, and it works. So that's what we're doing. Come into my Docker file, and at the very end of my Docker file, I have this like git config global add safe directory, and then I put it into the bash.rc. Let's do the same thing here. I'm going to say and echo add safe directory, and then I append that into home dev.bashrc so that when the shell opens up when I first open, it's just added and good to go. Okay, so that will get rid of this message, which again, you can see doesn't cause an issue in the build, but I hate warnings. I hate all that stuff. I like to clean it up, make it high and tight. So that should fix that. We could rebuild the container. I won't do that right now. Okay, so now that that's built, let's just do a idf.py flash monitor. Oh, okay. See, you're always bringing the fire. If you want to give me a name to call you other than just me trying to butcher your handle by saying eager, please stick it in the chat and I will refer to you properly. But he just put in the chat that this should work, which I think we're proving it does. Like, I'm getting the I'm the C program here. So that does work. He says the idiomatic IDF approach would be to add a kconfig option. And I don't know the jbuild file in the component, so that's interesting. I'd have to look at that more. But a kconfig would be so that you can go into menu config and set like an option of like which one you want to build. You could say like do the C version or the C++ version. We might have to play with that in a future stream. I like the idea. Okay, so this is working. I'm the C program. You can see that. And now what I would do is I can't just... I don't believe. Let's try it. We'll try it together. I don't think I can just say CPP version because stuff is already built. And so if I do this, CPP version equals 1, and I hit enter, I've run into this before, and then I do an idf.py flash monitor. I think it's going to say I'm the C program still. I could be wrong, though. Yeah, I'm the C program. And again, because the way the build system works is nothing, all I changed was an environment variable, and so it doesn't detect that anything else changed. So it's not gonna, it doesn't really rebuild anything based on that environment variable. So what we have to do, and this will kill you, if like you're doing this and trying to follow along at home, make sure you do the clean. And so what you do here is I just do an idf.py full clean. And now if I do CPP version, I can actually just do a, watch this, a flash monitor. It'll end up doing the build as part of it. We'll just do that. Remember, we put that message in there, so if we're paying attention, there it is right there. I'll try to freeze it. Building the C++ version. And Ears pointing out, this is why a kconfig option is more reliable, because if you actually go into menu config and select, I want to do the C or the C++ version, the CMake build system will catch that and force a rebuild. And so pointing out that it's more reliable than my janky way that I'm wiring it up here, but it's going to work for us. We're gonna start with this, and I think it'd be awesome to do a stream on making it a kconfig option, just as like a bite-sized learning thing. So cool. And I think if we come all the way down here, yeah, I'm the C++ program. Sweet. Okay. Great. So now we've got it building both ways. It's all in a single project here. And now we can start to compare. Like if we build it in C, build it in C++, and doing things in the, language appropriate way, how do they stack up? Before we do that though, I just have to fix a couple of things because I hate, like I said, warnings and things like that. I don't like it. And you'll see it right here. Detected size, 4096K, larger than the size in the binary image, which is 2 meg, using the size in the binary image header, which the chip I'm using, by the way, nothing special here. I don't know if you can see this. Yep, this is just a little room dev kit. It's like the dev kit C or something. Running an ESP32D. I did buy some of the S3 ones, which I'd like to play with eventually. But anyway, this is just a simple, you buy one of these, super cheap. Nothing fancy here, so you can follow along. I don't like this error message, so let's fix that. And if you remember from the last stream, we can use the sdkconfig.defaults to fix this. And what I showed in the last stream was how you would port from not using sdkconfig.defaults to using it. And now this would be an example of, you can see my SDK configs at this point is completely empty. I have it there because my top level CMake lists.txt references it. But how would we, like, what if you say, oh yeah, I want to set the flash size to 4 meg, what do I start typing here? Well, I don't know either. You could look it up online, but I'll show you at least what I think is the easiest way. I'm going to cancel out of this, and I'm just going to do an idf.py menu config, which will open up menu config, and let's see, we'll pull this up a little bit. And a couple things, you can search for it, or if you know where it's at, just navigate to it. I believe that's going to be in the serial flasher config. And you can see that the flash size defaults to 2 megs. Now, what you could do is come in here and change it. But remember, if we're using SDK config defaults, because this is a difference from the default, we should specify it explicitly there. And so if you just come down to the setting here, 4 meg, I'm not going to hit it. I'm just going to actually hit question mark. And when you hit question mark, it will show you what the name of the value is, and gives you a hint at what you would put in the defaults file. So the name of this is ESP tool flash size 4 meg. And you can kind of get a hint here like equals yes. So what we're going to do is I think I can just copy that. Oh, I knew that was going to happen. Dang it. You got to hit Control-Shift-C on Linux. Let's open that back up. Okay. Share flash config. Wonder if I hit question mark here. Yeah. Okay, see, it shows you all the different options. But we want 4 meg. So what I'm going to do is I'm just going to grab that there. I'm going to hit Control-Shift-C. And then up here, I'm going to say that equals yes. And again, I like to have I like to put it in under a comment that is the top level location, so to give me a hint of where it's actually at. So serial flasher config. Okay, and so I set it 4 meg equals yes. Now I'm going to exit out of, again, you got to be on your toes here. I'm going to exit out of menu config Oh, it didn't. Sorry. It doesn't like that. I've got this. Sorry. Comments are, I believe, like that. I think they're with Ash there. I can't just launch. Well, actually, I might be able to. I might need to do a build. Menu config. Okay, I did get an error that I didn't quite see. But let's come down here and see if that took. It did not. And the reason it did not, it's going to tell me, warning, ignoring malformed line, ESP tool, pi flash size equals 4 megs. I'm missing something simple here. And what I'll do in this case is I'm just going to come into the build directory. You've always got your SDK config right here. I don't have config in front of it. That's my problem. Okay. And do they all have to have config underscore? No, just config underscore. Okay. And if we look for it here, it's 2 meg. So if we just come into this file and look for 2 meg, you'll see config underscore, all the rest of that equals yes. So if we come back here, yeah, all of these are prefixed with config. Like that. Okay, now let's launch menu config. Shouldn't get an error. We do not. At least that, not that I saw. Serial flasher config. What? Flash size 2. What did I, why did it hate me that time? Full clean. Get up high, menu config. It looks like just changing the defaults doesn't trigger a re. Seems like every time you launch menu config, it should look at that. There we go. Okay, so I did a clean. Looks like SDK config defaults is only applied when SDK config file doesn't exist yet. So you'll do, anytime you make a change to this file, you're going to want to do a clean. I mean, you don't have to do a full clean. That's just a quick. I type it and it's done. But you'll need to delete your SDK config so that it rebuilds it. But as you can see, my flash size is now 4 megs. And if I do an idf.py flash monitor, we will no longer get that message saying there's a mismatch between what was reported in the image versus what it auto detected. And so we'll see that here in a second. Okay, and I think, how are we doing on time? Almost at half an hour. Try not to make these too long. Undefined oh. Yeah, you're selling me on the cake config more and more. Full clean. I need to do yeah, and see now I'm definitely sold on the K config. That's going to be our next stream, making this a K config option because I'm already forgetting what I call them. C version, okay. You do a C version dot. Oh, sorry, C version equals 1. Okay. All right. Okay, I did C version, yeah. It'll flash it. And you can see I don't get, I mean, I was getting this one before that has sort of that scary yellow, but don't worry. But I no longer get the mismatch between what's in the image header and what it auto detected. So we fixed that problem with our very first SDK config.defaults entry. Good. What I think we also need to do is make this a Git repo so that we can share it with everybody. I need to think about how I'll do commits on that so that people can get to specific, maybe experiments. I don't know. I'll think more. I'm just making this up as I go. I'm just curious of how this is all going to pan out. But what I want to get to is this is the C version. So we're going to do our very first test here. So it's running this code on the right. Let me bring up the CPP. It's running this version. I'm the C program, and it's using V task delay and port tick period MS. And if we do an idf.py, I think it's size, it'll show us, and I'm just going to grab this, copy it, and paste it like that. So we can get that information. I think I can get rid of this. Okay. And now what I'm going to do is an idf.py full clean. And we're going to switch over to the C++ version. And we'll always get that visual confirmation that we're looking at the right version because it prints it, over and over. I'm the C++, or I'm the C. I should have grabbed a little bit more information, which I'll show you here in a second. But anyway, like I said, the purpose of this stream is let's just get this started so we have a framework where we can just play around and see the difference. So I'm the C++ program, looks great. Let's run the same thing, idf.py size. And let's grab all of this. Come over here and do the same thing. Okay. And we're going to bring them right up next to each other and compare them. Okay, so you can see use static DRAM, data size, BSS size. And what you can do is just kind of come down the line here to just get a very high level comparison between the two. And you can see on most of these, C++ is slightly bigger in most categories. Use size in Flash, we went from 115K or so to 125K. This is a great baseline to see where the starting points are different. So, because once you get into a bigger program, if you're trying to choose between C or C++, if you're just doing the port, the difference you see might just be this baseline change and not the actual implementation change, if that makes sense. And so at the end of the day, total image size, we have 181, 197 over here, and we have 170, 405 here. So certainly right out of the gate, there is a small difference between the two, which makes me think of, whoa, eager. Sorry, we're getting some stuff in the chat here. IDF size has a feature to compare two builds, showing the size difference. Can you expound on that? Can you tell me a command I can run? That would be incredible. I would like to learn, or just a link to some documentation I could read. That would be amazing and make this potentially a lot easier. But yeah, it doesn't contain the link here because Twitch just turns it into star so that people, I guess, can't send you malicious links. Can you drop it in the Discord real quick? I'll grab it out of there. Just in the general channel. Yeah, sorry, links don't work in the Twitch chat. That might be a setting that I can change, but yeah, just eager, whenever you get a chance, if you could drop that link in the Discord, just in the general channel, I'll take a look at that. Apparently, there is a way to compare sizes between builds. There's another command here that was like, well, let's just do idf.py. I think it's like component size or size components. So if we do idf.py size components. Okay. Yeah, no worries, Igor. Just if you get a minute, and I can search it up too. But this will show you, and this is really cool. This will show you for every object that it's building. So it gives you the same sort of high level. This 181, 197 that showed here. This will show you also. Well, now that I know that it shows you the totals too, I would just run this command every time. It also shows you like where the file size difference is coming from. So let's end on this. Like let's grab this. Oh, why didn't it? Why are you messing with me? Control Shift C. Oh, I know why. Because I'm a dummy. Okay. No, it's still copy. Come on. There we go. Here, got it. Comparing two binaries. That is awesome. Yes, I will look into that. Maybe do a little stream on that as well. That would be super cool. Okay. It's going to be hard with the size of the window I have here. But it helps you see the size. Let's just look at it down here for now. It helps you see the size, like for each type of memory that's going to go into the final binary. Like it shows you like libc is using, and it sorts it descending from flash total. So like this is the total flash space that libc is using when I build it for, this is a C++ version. And then you'll see some like lib standard C++. This is contributing, 10,000 bytes, which if you look at the final difference between it, we went 181 with 170, like that's like 11,000 byte difference, 10,000 of that. So most of it is coming from this C++.A, which I'm assuming, and we'll run it really quick here before we close out, is not going to show up on the C version. So this is just bare bones C++ stuff that you have to have. Okay, so let's full clean, and we'll do C version equals 1. Pi build. Let that build. Shouldn't take very long. Was it size components? Component size? Size components. Okay, and so yeah, right away you see there is no libc C++ down here. That was right up here at the top. That was like around 10K. That's not there. So this is a great way for you to see like where, also if you're trying to optimize code, and you need flash space, this is a great command to run to be able to see, oh, this is the component that I should focus on. A lot of these are going to be built-in IDF things that you didn't write, but you will eventually see yours in here, like this, I believe libmain A down here. So like this is the main file. I believe that's correct. So in the case of C, it's 41. I'm going to take all this, Control Shift C. There we go. All right, I'm going to bring this back down, bring this up. So lib main over here, yeah, it's just harder to look at this way, it was 41. And my lib main down here was 55. Okay, so this is the kind of comparison that I want to do, and I want to be able to get into like it locked in so that we can quickly like write some C, maybe run some scripts or some commands and see like oh hey, the C version used this much more RO data versus the C version or text data, and then here's the flash total difference between the two to really give you an idea and myself an idea of like what's the difference. And so if I'm looking like as a quick getting started example, in the C++ case, 55 bytes versus 41. Okay, so what are we talking about there? We're talking about 14 bytes. And so then you can start asking yourself questions like, do I need 14 more bytes? And beyond that, is 14 bytes a fair trade to be able to write code that looks like this versus code that looks like this? Now I get it, it's a 2-line example and really just a 1-line difference, whether you want to say v task delay or standard this thread sleep for chrono. But to be honest, if I'm just getting started, if you were to say, hey, you could write this instead of this, if you could use this thread sleep for and use the chrono library versus using vtask delay, and it only cost you X number of bytes, for me, definitely worth the trade, because I prefer to read the chrono. But I think a lot of people, their instinct would say, oh, this looks very C++y over here on this side, and it's probably just bloating flash, when bloating is a relative term, and that's what I want to find out with these. So, which makes me think, I wonder if there is a chrono. Yeah, I would love to be able to do like quick comparisons between these. I'll look at that documentation, Igor, because I'd love to see like exactly what the differences are. Um, so yeah, maybe I'll have that in a future stream to where we can look at the difference between the two. So this is the I want to mix these in every once in a while, sort of the C versus C++, do some actual data gathering to see the difference and what the trade-offs are, and maybe help people feel a little bit better about C++. Again, there are times when raw C is maybe really important to really squeeze out bytes of flash size. If you're down to like, I need a dozen bytes here or there, you probably want to be in C. But if you've got some headroom, I don't know. I'm a fan of C++ personally, and until I understand all of the trade-offs I'm making, I want to keep collecting data. So, all right, that is going to do it. I think we're going to wrap up for today. A little longer than I wanted to go, but a lot of great stuff. Igor, again, I can't thank you enough for all of the like incredible value that you bring into the community, and then I'm just regurgitating it and putting it on stream form to try and help other people along their journey with ESP 32 and the ecosystem. So thanks everybody for watching, and we will see you next time. If I can figure out how to stop the stream. Obviously, I don't know how. See you guys next time.